Let's get some practice with our exponent properties, especially when we have integer exponents. So let's think about what 4 to the negative 3 times 4 to the 5th power is going to be equal to. And I encourage you to pause the video and think about it on your own. Well, there's a couple of ways to do this. One, you say, oh, look, I'm multiplying two things that have the same base. So this is going to be that base, 4, and then I add the exponents, 4 to the negative 3 plus 5 power, which is equal to 4 to the 2nd power. And that's just a straightforward exponent property. But you can also think about, why does that actually make sense? 4 to the negative 3 power, that is 1 over 4 to the 3rd power. Or you could view that as 1 over 4 times 4 times 4. And then 4 to the 5th, that's 5 4s being multiplied together. So it's times 4 times 4 times 4 times 4 times 4. And so notice, when you multiply this out, you're going to have 5 4s in the numerator and 3 4s in the denominator. And so 3 of these in the denominator are going to cancel out with 3 of these in the numerator. And so you're going to be left with 5 minus 3, or negative 3 plus 5 4s. So this 4 times 4 is the same thing as 4 squared. Now let's do one with variables. So let's say that you have a to the negative 4th power times a to the, let's say, a squared. What is that going to be? Well, once again, you have the same base. In this case, it's a. And since I'm multiplying them, you can just add the exponents. So it's going to be a to the negative 4 plus 2 power, which is equal to a to the negative 2 power. And once again, it should make sense. This right over here, that is 1 over a times a times a times a. And then this is times a times a. So that cancels with that cancels with that, and you're still left with 1 over a times a, which is the same thing as a to the negative 2 power. Now let's do it with some quotients. So what if I were to ask you, what is 12 to the negative 7 divided by 12 to the negative 5 power? Well, when you're dividing, you subtract exponents if you have the same base. So this is going to be equal to 12 to the negative 7 minus negative 5 power. You're subtracting the bottom exponent. And so this is going to be equal to 12 to the, subtracting a negative is the same thing as adding the positive, a 12 to the negative 2 power. And once again, we just have to think about, why does this actually make sense? Well, you can actually rewrite this. 12 to the negative 7 divided by 12 to the negative 5, that's the same thing as 12 to the negative 7 times 12 to the 5th power. If we take the reciprocal of this right over here, you would make the exponent positive. And then you get exactly what we were doing in those previous examples with products. And so let's just do one more with variables for good measure. Let's say I have x to the negative 20th power divided by x to the 5th power. Well, once again, we have the same base, and we're taking a quotient. So this is going to be x to the negative 20 minus 5, because we have this one right over here in the denominator. So this is going to be equal to x to the negative 25th power. And once again, you could view our original expression as x to the negative 20th, and having an x to the 5th in the denominator, dividing by x to the 5th, is the same thing as multiplying by x to the negative 5. And so here, you just add the exponents, and once again, you would get x to the negative 25th power.